there, people. Today we are talking about derivatives of exponential and logarithmic functions. So we are going to write some notes down. I'm going to do a few examples. The rest of the examples we will do in class. So this should be a quick up and down. So we are talking about derivatives of e to the x, a to the x, which a is a constant, natural log of x, log base a of x, and then extended power rule. Logarithmic differentiation, there's no rule for that, but we will do that example in class together. So our first derivative is right here. So we have d dx of e to the u is just e to the u times the derivative of u. So however you want to write it, I rewrote what that is just so you could see it a little larger, but that is what I would like you to look at. Next thing I have is an example. So on this example, I have e to the x cubed. So my derivative is going to be e to my exponent times the derivative of my exponent. Well, my exponent is x cubed, so this becomes 3x squared. I usually write that in the front, so I get 3x squared times e to the x cubed. And you can see that that's what the book got for their notes as well. On the third page here, we are finding the derivative of a to the u, and again, a is a constant. So as we do this, it's going to be a to the u times the natural log of a times the derivative of u. Okay. The next one is your natural log of x. So if you are finding the derivative of the natural log of u, it's 1 over u times the derivative of u. Again, if I'm going too fast, please just pause the video, write it down. So an example of this, we are doing the example here. First thing I want to do, it's going to be 1 over my u value, and we're making u equal to 3x squared. So 1 over u times the derivative of u. So my derivative is 6x. If I rewrite it, I get 6 over 3x squared. This can be reduced. And 3, 2, one of the x's is gone. So I end up with 2 over x. And you can see that that is what the book's answer got as well. The next one is the derivative of log base a of x. I'm sorry about the shine here, so that's why I'm rewriting it. So log base a of u. This is going to be 1 over u times the natural log of a, whatever your base is here, times the derivative of u. Okay, this one probably not as common as the natural log base a, whatever a is, but we do it sometimes. Okay, the next rule that we have here, we are talking about the power rule. So again, you are just bringing the exponent down, subtracting 1 from the exponent, and make sure that you're multiplying by the derivative of the exponent. There's nothing really exciting about this. So the example here, I'm just going to write it bigger. This is the cube root of 4. That's the exponent. Whoops, can't see it. There you go, cube root of 4. So we're still doing the same thing. We are still following the power rule. The power is just this number. It's not a nice integer, which is fine. So you're still going to bring the exponent down to the front, subtract 1 from the exponent, Can't combine like terms, so it stays like that. And then we multiply by the derivative of the inside. So it's a chain rule, and the derivative of inside is 5. So again, they wrote it like this. This is how I would have written it too. Cube root of 4 minus 1. Okay, so logarithmic differentiation, which we will do an example on Monday. It's just sometimes the properties of logarithms can be used to differentiate, and sometimes they can't. When you have something like an x to the cosine of x, so you have a variable in both the base and up in the exponent, then you're going to do logarithmic differentiation. So we will do an example of that on in class on Monday. Thanks, guys.